Kamu dulu.
Dia masih buat kan? Dia masih buat kan?
Okay, just that. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon to all viewers. Thank you everyone for watching us streaming live now through School of Electrical Engineering's Facebook. Hopefully everyone can hear my voice this time. Okay, welcome to our second series of webinar on research and innovation brought to you by School of Electrical Engineering, Faculty of Engineering, University Technology, Malaysia. Without further ado, I would like to invite Professor Dr. Muhammad Kamal A. Rahim, the Associate Chairman of Research and Academic Staff, School of Electrical Engineering, UTM, to introduce our guest speaker for today, Associate Professor IR, Dr. Pauzi Abdullah, Director of Center of Electrical Energy Systems. Over to you, Prof.
Thank you very much, Puan Sharifah Huzaimah, for introducing this event. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And salam sejahtera to all viewers of our FB Live today. Once again, thank you to all the viewers that follow this live streaming webinar through FB Live School of Electrical Engineering. My name is Professor Muhammad Kamal Rahim. I'm the Associate Chair of Research and Academic Staff, School of Electrical Engineering, Faculty of Engineering, University Technology Malaysia. Our topics today is entitled Addressing Current and Future Challenge in Electrical Energy Systems. That will be presented by our Director of Electrical Energy System, Associate Professor IR Dr. Muhammad Pauzi Abdullah. Before he gave his presentation today, I would like to introduce about our speaker. Dr. Muhammad Pauzi Abdullah is an Associate Professor at the School of Electrical Engineering, Faculty of Engineering, University of Technology Malaysia. He is currently the Director at the Center of Electrical Energy Systems, Institute of Future Energy, University of Technology Malaysia. He is a professional engineer registered with the Board of Engineers Malaysia and Chartered Engineer registered with the Engineering Council, United Kingdom. He is also a senior member of the Institute of Electrical and Electronic Engineer, United States of America. He received the bachelor's degree in Electrical and Electronic Engineering from University Tenaga Nasional, or short form is UNITEN, Malaysia in 2002. Master's degree in Electrical Power Engineering and doctorate degree from University of Strathclyde, Glasgow, United Kingdom in 2003 and 2008, respectively. His research interests include power systems analysis, system security, deregulated electricity market, and demand-side management. He is actively involved in various professional organizations, such as the Institute of Electrical Electronics Malaysia and Power and Energy Society Malaysia. Currently, he is a chair-elect for IEEE Malaysia sections from 2019 up to 2020. Now, I would like to invite Associate Professor IR Dr. Muhammad Pauzi Abdullah to give his presentation. Welcome, Prof. Thank you.
Dear viewers, imagine 50 years from now, what do you think your electricity will look like? Do you think that you will have a free electricity? Will you still have TMB? Will the electricity bill or the tariff still will be low or high? What are the challenges that we have to face, especially in this electrical energy system? Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all viewers. Thanks a lot, Professor Kamal, for the nice introduction. Okay, today I will give a topic on addressing current and future challenges in electrical energy systems. What I'm going to do in this webinar, I'm going to take about 40 minutes of your time to highlight what is actually the challenges in electrical energy systems. Right. Okay. So the highlight for this webinar, I will divide this webinar into 3 sections. First section is about introduction to electrical energy systems. This is for benefit of the viewers who are not from electrical engineering background. So I will give some highlight what is actually the important parts of these electrical energy systems. Second section, I will highlight what are the current and future challenges in electrical energy systems. I'm sure the challenges is a lot, so I will highlight some of the important challenges that we have to address. And the third section, I will talk about how we at CIS, Center of Electrical Energy Systems, how we address some of the challenges. Right. Okay. So if you look at the diagram, this is a basic component of electrical energy system. So basically you have this power plant, okay, you have power transformer, this is transmission lines, then you have another power transformer here, you have distribution line, and this you have these different customers. Okay, so this is the complete electrical power system. So if we go in more detail, so the power plant is actually part of this generation. So in power system, the first part is generation. So you have a picture over there in this diagram. This is a real power plant. This is Parker Power Station, which is a combined cycle gas power plant. The size, the capacity is 1.4 gigawatt. So, but I share this this picture because this power plant is already decommissioned earlier this year because this power plant already operated for 33 years. Okay, this is a very old power plant. Okay, this is Parker. Then the next important part of this power system is transmission. Okay, so if you look at the picture here, see, I believe that you saw this. Okay, when you use Plus Highway, you have a lot of this. This is transmission system. Then another important part is distribution system. Okay, all right. I think for the old residential area, you still have this overhead distribution line. For the new residential area, most of the distribution line are underground, so you cannot see it. Okay. Then the next important part of this power system is the customers. Okay, so basically the customers you can actually divide it to industrial customers, commercial customers, and residential customers. So if you look at this diagram, so most customers, majority of the customers is connected to distribution system, but also there's also a few industries, okay, in which they are connected directly to the transmission system. This is a very big industries like steel mill. Okay, their consumption is a very high. So that's why it's actually directly connected to the transmission system. So that is basically the basic component of electrical power systems from generation, transmission, distribution, and customers. Right. So let's go more specific on generation. So this is a very new data. So this is actually, if you look at the range, the date range actually from 15th June until 22nd of June, yesterday. So this generation mix for Peninsular Malaysia. So this generation mix, okay, the graph shows generation mix of solar, okay, others generation, okay, hydro, gas, and coal. So if you look at the diagram, so you can see that in Malaysia right now, coal power plant contribute the most generation per hour to meet our demand. So if you look at here the diagram, somewhere around what 70%. Okay, so you can see that almost 20 plus, okay, nearly 30% from gas. Hydro, not that much. Okay, maybe 5%, around 5%. Okay, then you have solar. Okay, solar is around what? Around 2%. So this is actually the utility scale solar power system. So this is actually the main generation mix for Peninsular Malaysia. This is the real data. Okay, so you can see that most of our generation is actually coming from coal power plant. Okay, right. So this is actually the total energy generated from different generation. So here you can see that here we have more detail. Okay, for last Thursday, okay, solar is around 1.6%. It only generate around 264 megawatt hour of energy. Okay, others is not zero. It has some numbers, but because the number is too small, that's why it actually translated to 0%. Okay, then you have hydro 317 megawatt hour. Then you have gas, okay, 5,000 megawatt hour. Then you have coal, 9,000, nearly 10,000 megawatt hour. So you know that, okay, how crucial coal power station to supply to meet the demand of electricity in Malaysia. Okay, that is actually some data, okay, for a generation for Peninsular Malaysia. Right. Now let's look at the transmission and distribution system in Malaysia. Okay, so you must understand that electrical power system, electrical energy system is the most complicated and the most big system. So if you look at here, okay, for the transmission line system in Malaysia, okay, it actually divided into different voltage level. Okay, as for layman term, in order for you to know how big the voltage level is, the bigger the tower, the higher the voltage level. That's actually the easiest way to identify whether that transmission line is 500 kV, 275 kV, 132 kV, or 66 kV. So basically, if you look at the data, if you look at the table, for 500 kV, we have 784 kilometers. Okay, it's not that a lot, okay, but we do have that 500 kV transmission line. But look at 275 kV. Okay, we have more than 9,000 kilometers of transmission line in Peninsular Malaysia. See how huge the transmission line is. Then look at 132 kV. Okay, more than 12,000 kilometers. Okay, right. Then okay, so well, you can see that comparatively in Sabah and Sarawak. Okay, but let's look at the distribution line. So for distribution line, for the overhead distribution line, we have more than 500,000 kilometers of distribution line. See, the length is huge. You can imagine the cost of having that asset. Okay, then for underground distribution line, we have more than nearly 700,000 kilometers, okay, of underground line. Right. Hey, this is, I want to share with you the maximum demand. So if this is the electricity consumption demand in Peninsular Malaysia for one day. So in this case, this data is for last week, 15 June 2020. So if you look at the y-axis here, this is a megawatt. So this is the total electricity consumption in Peninsular Malaysia, meaning that you add all the electricity consumption in all industry, commercial buildings, and all residential. We add them together, will give you, this is the total consumption of Malaysia for 24 hours. So here is at 1 a.m., 2 a.m. until, okay, 24 hours at 12 a.m. midnight. Yes, you can see the pattern. This is the pattern for electricity consumption in Malaysia. Well, okay, if you look at here, okay, it becomes lower and it starts to increase at 8 o'clock, 9 o'clock. Okay, this is where the people starts working. Okay, you can see the pattern start to increase, and it reach its maximum around 4 o'clock, and then it start to drop again. Okay, maybe because here all the office starts to close, people start to go back, but then it increase again around 8 o'clock, 9 o'clock at night. Okay, it shows that people already reach at their home. Okay, they already started watch television or start resting at home. So that's why the consumption start to increase again. This is the load profile. We call it load profile or energy consumption of Malaysia, 1 day electricity consumption in Peninsular Malaysia. Okay, right. Just for the sake of a comparison, okay, I share this data. Okay, this is a data because we still in this PKPPP. Okay, we still not I would say heal 100% from this MCO. This the orange line data is actually the electricity consumption data 2 days before MCO. So you can see the maximum demand. Okay, and if you compare the maximum demand after MCO, see, yeah, we have a drop about 1.2 gigawatt. You see how it affect. You can see how the MCO affect the total consumption of the whole in the Peninsular Malaysia. Okay, maybe some of the industry are not yet fully open. Okay, maybe some of the commercial building is still not fully operate. So that's why we have the demand is a bit lower. Well, maybe many of you are curious, what is actually the electricity consumption during MCO? What is the consumption? Okay, I'll share with you. Okay, this is the electricity consumption in Peninsular Malaysia during MCO. See how big drop it is. Okay, imagine from 18.6 gigawatt, it dropped during MCO. It dropped what around 6 gigawatt. So how big it is? Just like more than what 2-3 big power plants capacity. So this is a very big drop in electricity consumption during the MCO. Well, that is actually expected. Well, because all the industries are closed, all the commercial buildings are closed. But again, if you look at in more details, residential customer maybe contribute around 30%. Okay, so around 70% actually from commercial and industry. So if the commercial and industry are closed, do you think that supposedly the electricity consumption will be much less? So the answer to that, maybe because now everyone start working at home, so the electricity consumption for residential customer becomes increased. So that's why it does not drop maybe around 50 or 60%. It just dropped around 33% of the, if you compare it to the electricity consumption before MCO. Okay, that is just for your information. Okay. Right. So this is another important information. Okay, when we talk about electricity, most customers, okay, most public, okay, most people, they only think about tariff, how much they have to pay. Okay, so electricity price, the electricity bill is not an easy, it's not a straight forward bill. Okay, it's complicated because first you must understand that there's a tariff block. You must understand first. Okay, I know that there's a hot issue for the past few weeks, okay, about this electricity bill, but I think, okay, you need the customers need to understand that you have electricity block. Okay, so if you look at here, this is the electricity block I share. Electricity block for domestic or residential customers, and then for the commercial customers. So if you look at here, right, the cheapest electricity tariff is for domestic customers for the first 200 kilowatt hour, which is around 21.8 cents. For me, this is really, really low, okay, because if you compare to other commercial and commercial tariff, is the tariff is higher than that. Okay, right. So you have this different block: 200, next 100, next 300 kilowatt hour, next 300 kilowatt hour. So the meaning from this block, you must understand that if your consumption is double, your electricity bill will not be double. Your electricity bill most probably will be 2.5 or triple. Okay, because of the increasing block tariff. Okay, so if you use more, okay, you have to pay more. Okay, that is actually basically how the block tariff works. If you look at this commercial, sorry, okay, right, for commercial, you have first 200 kilowatt hour, then you have next kilowatt hour, and on and so on. Okay, you have different tariffs. I don't want to go to details for that. Okay, let's go to the next. Okay, next part, I want to focus on challenges. Okay, I just already gave you some of the background about electrical energy systems. Okay, what are the challenges in electrical energy systems? When we talk about challenges, okay, this is the first and foremost, the most important challenges that we have to address. We call it energy trilemma. Okay, normally we talk about dilemma, right? It's only between two things. This is trilemma. Three things. First, you have to consider security of supply. Second, you have to consider the affordability. Third one, we talk about sustainability. Okay, for example, okay, right. So when we look at here, just now already shared in Malaysia, the main our generation actually is fueled by the fossil fuel. Actually fossil fuel, the coal power, the coal and gas is the main fuel for our generation. From the generation mix, you can see about 60%, 60%. So more than 90% actually come from gas and coal, right? So if you want to have security of supply, we need to diversify our generation fuel. We can only depend on coal. Why we cannot depend on coal? Because firstly, in theory, coal power plant, coal, because we use coal, arang batu, is cheap. The problem in Malaysia, we don't really have coal. Okay, unless you have your own coal, maybe we don't have problem. Okay, because we have to buy coal from other countries. Let's say one day the countries no longer want to sell coal to us. What happened? Imagine if you look at here, our generation mix, we use around more than 60% of coal for our generation. What happened? Okay, gas. Okay, of course, gas. Maybe one day it will not last. Okay, of course we have gas, but for how many years we should depend on gas? We have to think about that. So we need to diversify our energy sources. Okay, our fuel for a generation. So that's why we go for this renewable energy. The problem of renewable energy, there's a lot of renewable. For example, we look at this solar PV. Okay, maybe 10 years from now, okay, we cannot afford that because it's too expensive. Okay, so that's why there comes the second point of the trilemma, affordability. Can we afford that? Okay, can we afford that? Okay, that's another issue. Okay, maybe the technology is good, but can we afford that? Okay, then once we can afford that, then the third lemma, is it sustainable? Okay, will it cause this pollution? Can we have it continuously in the long run? This is actually the issue that we have to address. So when we talk about energy, we have this trilemma. Okay, right. So generation, our challenge is we too dependent on fossil fuel for electric generation. I said we depend on coal, okay, oil, and natural gas. Okay, we too depend on that. So that's where we need this renewable energy. Okay, now everyone is talking about renewable energy, whether it is solar PV, solar, okay, it is wind energy. Okay, unfortunately, we don't have wind energy in Malaysia because throughout the study, basically our wind in Malaysia is not that high. Okay, I would say just sepoi. Okay, so it's too slow to have a big wind turbine. Okay, maybe we need to do that small speed turbine whatever. But right now, okay, the most preferred renewable energy for Malaysia, or the preferred choice in Malaysia, is a solar PV. Right, but people think about, okay, we have solar PV. Why don't we just install so many solar PV in Malaysia? That solve our security problem, the energy security problem, just the one that I just mentioned just now. Why don't we just have this? right? So it's not as simple as that. It's not simply you have PV, then you solve problem. Okay, so that's why I share this curve. This is actually curve of CAISO. CAISO stands for California ISO. This is actually the electricity market in US, in California. They call this duck curve. Duck curve. Why it is known as duck curve? Because it has a shape of duck. So that's why they call it duck curve. Okay, let's forget about the duck. Let's look at what is actually the importance of this duck curve. Right. So if you look at here, if you look at the graph, originally, okay, this is the load profile, the gray colored line of load profile. Imagine I share already your electricity consumption of Malaysia. This is the electricity consumption of California. Originally, this is the load profile or the load consumption of California. Okay, but after few years, in 2012, they managed to change the load profile to this. Why? Because they started to have lots of PV. So that's why most of the generation is supplied by solar PV. So that's why the load curve become like this. So meaning that the generation the conventional generator no need to supply the demand because it's being met by solar PV. But then see what happened? It become lower and lower. It creates new problem. You may solve one problem, it creates new problem. What is the new problem? Okay, because your solar PV only can last until what? 6 o'clock, 7 o'clock, right? What happened after that? See what happened? Okay, the demand increase. You need to ramp up the generation around 13 gigawatt in just 3 hours. So meaning that, okay, because once the solar out, you need all the available generator, especially from the fossil fuel generators, to ramp up the output to 13 gigawatt in just for 3 hours. Imagine the technical difficulty in meeting that. So again, okay, we have to address this. How to address these challenges. Okay? Right. Another issue. Right. Let's say that we talk about solar. Which one is preferable? Utility scale? Or in Malaysia, we talk about, if you ever heard, large scale solar? Or you have this small scale, it's distributed solar PV, in which we have this a lot and you install your solar PV at your home or in a commercial building. That is a distributed solar PV. Okay, utility scale, we talk about very large. Okay, for utility scale, maybe we'll talk about 80 megawatt. In Malaysia right now, I think the highest is 100 megawatt solar farm. It's really huge. Okay, so which one is the preferred one? Of course, in terms of cost, okay, in terms of because the large system, of course, you will produce cheaper in terms of cost, okay, per kilowatt hour. But again, we also have problem. Yes, solar power. When we have this all concentrated this solar farm, okay, the output of PV is depend on the weather, or it depend on the cloud. Even with slight shading, the output of the solar power can drop tremendously. What happened? Okay, when the solar output from the PV drop tremendously, the conventional generator need to pick up. Okay, because if the generation become lower than the demand, what happens? The frequency will drop. So it adds complexity to the system. Okay, again, then if you go to the small scale distribution solar or the solar PV at home, okay, again, you need to encourage customers. You have to encourage customers to install the solar PV. That's why where you have all the incentive. Previously, we have this fee and tariff. Okay, for the incentive for the customers to install solar PV. Then currently they change it to net energy metering. Okay, so if you have a solar PV, okay, whatever you generated, let's say that 1 month you consume 1,000 kilowatt. Your solar PV generate 400 kilowatt. You deduct it. Okay, so you basically the net is 600 kilowatt. Only 600 kilowatt you pay to TNB. So basically that is the mechanism. Okay, the NEM. Okay, just to actually to encourage customers to really install this solar PV. But of course, there's a health problem. Okay, because we already have research. Okay, we at the Center of the System, we identified the at the current rate. Okay, the NEM scheme is only profitable for the big customers. For that meaning that if your house is big, or your consumption is really big, installing solar PV is good. But if your city bill, your consumption is low, let's say maybe just 100, 200 ringgit, installing solar PV will not benefit you at the current price. Okay, maybe in a few years time, once the cost of solar PV becomes lower, and maybe it will benefit the small customers. But currently, it does not benefit. Right. What are the other challenge? Okay, we have the problem in transmission distribution system. The system are aging. Okay, need upgrade to meet growing demand. Okay, need investment. You can see how big the system is. We talk about hundred thousands of kilometers. Okay, it's a very huge system. Okay, lot of investment needed. How to delay upgrade? So that's why we talk about maybe we can actually try to reduce the consumption or try to delay the increase in consumption so that we can delay in upgrading the transmission line. So there's a lot of challenges in that, yeah, especially when we talk about we want to build a safe, reliable, and cost-effective system, right? What else? Okay, we have also challenges here about, okay, for electricity customers, okay, for industrial customers, right? One of the challenges is to have this efficient energy management. Okay, basically the electricity customers, industrial customers, okay, they consume a lot of energy, right? So the challenge is how to save electricity costs, okay, by properly managing their energy consumption. Okay, so this is a challenge for industrial customers. Okay, that's why a big company, okay, they need to do this energy audit. Okay, because electricity is not something common to everyone. Okay, you need to really have this energy audit to know how your load consuming your electricity, how you use your let's say for your line production line and all that. You need to know how to manage. Okay, because for domestic customers, if you look at the electricity bill structure, okay, it's not like residential customer. They have this maximum demand charge. You have this power factor penalty. Okay, you have this energy charge. Okay, so this actually, okay, if the energy consumption can be managed efficiently, it can actually save electricity costs. That's a challenge for industrial customers. Then you have this power quality problem. Okay, what's power quality problem? Okay, see, I share you two graph. Okay, I think for the viewers are from electrical engineering background, you know this is actually sinusoidal signal. This is a voltage and current signal. So it is just a sinusoidal signal. But if you look at here, this is a drop in amplitude. This is a voltage sag problem. It's not long. Okay, if you look at here, just a few milliseconds. And if you look at the next graph, this is harmonics. You see, it's supposed to be a sinusoidal shape, but you have a strange shape, like a shape of a ghost or whatever. Okay, this is harmonics. Okay, why this is a problem? Okay, for this actually, okay, this we call it power quality problem. You don't have problem with supply, you still have the supply, but the quality of the supply. Okay, what will happen? Okay, water sag, okay, can cause the motor machine stop running. See how critical it is for factory. If your motor machine stop running, what happened? The production line stop. So they need few hours just to start up everything back. So how much loss they will suffer? So this is very critical, right? Then you have harmonics. Harmonics also it can problem. It can cause heating, increase in losses, equipment malfunction in the long run. So this is very critical. Okay? Right. For electricity customers, what are the challenges? For commercial customers, the main user are air conditioning, and lighting. This is the main user. Okay. So for commercial customers, they need to understand the energy consumption charge, maximum demand charge. What is the maximum demand charge? What's power factor penalty? What is the time of use tariff? You know that you have time of use tariff, and the new one enhanced time of use tariff. you know, you can actually save electricity. Commercial customer can save electricity by changing from TOU to ETOU tariff. Okay, so that's why this is the challenge for commercial customers to understand this. Okay, so that's why we need to help them. Okay, then efficient energy management able to save electricity. Because I share you some diagram. The difference between TOU tariff and enhanced ETOU. Okay, I have students who already work on this. We can see that the benefit of this, but maybe this is actually not a common for the public. Okay, so that's why we need to address this as well. Okay, electricity customer for residential. What are the challenges? Okay, for residential customers, I think the main challenges is the lack of awareness of electricity usage and conservation. Okay, so they don't really know what is actually how each appliances or electrical equipment at their home consume electricity. Okay, I think the most simple way is like this: anything to do with cooling and heating consume lots of electricity. That's a general rule. It's very simple. So basically, aircon, your refrigerator, your electric iron, your electric cooker. If you keep baking cake, okay, maybe during MCO, of course your electricity bill will increase. Okay, anything with cooling and heating will increase, will consume more electricity. Also, it's very difficult to change energy habits. Okay, I think this is actually, I think it's not only energy. It's very difficult for us to change our habits sometimes. I will share this diagram. This is actually the study I think done in England. I'm not mistaken. I can check the source I got. Okay, from the survey, okay, 42% of customers are not satisfied with the bill. Okay, more than 70% think that the bill is too high. Okay, I got the bill 5 times bigger than the previous one. It was a shock. Okay, some say they don't understand. Okay, the bill is very complicated. I don't blame them. Okay, because for the layman, for the common people, I think the electricity bill is too complicated. You have this, you have to multiply this. Then you have, yeah, I agree with that. Okay, others we have this. Some of them say the bill are not detailed enough. Then maybe these are people who have with technical background. Okay, they have that feeling. Okay, but this is actually among the challenges. Then future smart grid. Okay, in the electrical system, there's a term about smart grid, future smart grid. Are we ready? Right. So this is just some background. This is current grid. I already mentioned to you. We have this generation, we have transmission, distribution system, and customers. What the smart grid will look like? First, future smart grid. First, you have large RE integration. You have large renewable energy integration in the system. You have lots of PV. You talk about high penetration. It's not just a small penetration, high penetration. What else? You have smart meters. Okay, in future, okay, your house will have smart meter. Okay, you don't worry about your electricity bill comes 3 months late or what. Okay, it can automatically after 1 month you can already. In fact, you can know your city consumption every half an hour or real time. That is the use of smart meter in future. Then you have sensors, lot of sensors in the system. When a lot of sensors, meaning that we have lots of data. You can see that. Then you have two-way communication. Okay, communication from system operator and each component in the system. Okay, you can the system operator can have access of data to every component in the system. Then you have storage. This is also very important in the future. You have storage, your own storage to store energy. Then you have EV car. Okay, as part, okay, you have EV car, lots of EV car in the road. Okay, so basically, your car will be fueled totally from electricity. Okay, right? You have real-time electricity price. You know what actually the cost of electricity at that time. You have real-time because everything is interconnected. You have all communication, two-way combination. You know what actually the electricity price at that time. Okay. Then you have smart home. Okay, your home becomes smart. Okay, you can respond automatically from the city price. Okay, I just give you a scenario. They say that at particular hour, your system notice that the city price becomes higher. Okay, your home can react automatically, switch off your aircon. Why? Because the city price right now at this hour becomes too high. So stop right now. Okay, stop at the moment. Okay, after the price go down, okay. Oh, we can have that. Okay, this is the future of smart grid. Then, right. Okay, so with all this is will create. Okay, of course, it will create lots of new opportunities, lot of advantage, but also create lots of challenges. First, if you want to have this future smart grid, first you must have the manpower. You must have human resource to able to operate this kind of system. The system will be too complicated. Okay, we must engineer the future engineers. We must train them. Okay. Also here, if you can see from the smart grid, it's not about electrical system only. It's not about electrical power. You need about the communication. You need this IT because a lot of communication. We talk about big data. Okay, so in the future, big data is important. How you address it, how you use all this information. So this is what will be challenging for us. Okay, right. So here now the third section, okay, which is addressing the challenges. Okay, what I want here in this section, I just want to explain some of the work that we do at the Center of Electrical System to address some of the challenges. Okay, as I mentioned earlier, the challenges is huge, too many challenges, but we at CIS, Center of Electrical System, we try to address some of the challenges. Okay, some of the facts, this is our logo, some of the facts and figures for the CIS. CIS actually established in March 2009, okay, slightly above more than 11 years old. Okay, so this is the previous director. Previous director is actually the pioneer is Professor Dr. Khalid Muhammad Noor, already retired, and the second director is the Professor Dr. Muhammad Yusri Hassan. Okay, I'm the current director for CIS, and the deputy director is Dr. Dalila Ahmad Said. Okay, so basically our manpower, our people in the center, we have 11 research fellows coming from different background, okay, different expertise. We have one research officer, two assistant engineer. We have currently 35 PhD students doing research in the center, in which 18 students are actually international students coming from different countries, from Nigeria, okay, from Indonesia, okay, from different parts of the world. Okay. We have 12 master by research students. Okay, this is the research area. Research area, energy efficiency and management, okay, electrical power quality, renewable energy, PV, wind, power system analysis and optimization, smart grid applications, and the regulated electricity market. So if you look at these research areas, all these research areas actually try to address all the challenges that are already explained just now. Okay. Right. Also, we have provide training, short courses, professional short courses. We have this efficient energy management, short course, electrical energy audit, power quality, and also smart grid. Okay. We do have this consultation. Our main consultation work is on energy audit. Okay, that's why I can comment on how important to this energy audit, because we identify that some of the big industrial customer, commercial customer, okay, they lost the opportunity to manage their energy consumption efficiently, because you can save lots of energy by doing that. Okay. Then also we also do this some community service. Okay, we do this some especially we do talks on electricity saving awareness. I said education is very important. We need to educate people on how to use electricity more responsibly. Okay, I also do this work in energy audit for schools. I just want to share some of the pictures. This is the research fellows in the center. Okay, you can see some of the very senior professors, okay, with different backgrounds. So the Professor Zainal, for example, is the expert, I would say the Malaysian expert in power electronics and solar photovoltaic. Okay, we have Professor Engineer Dr. Muhammad Yusri Hassan, who also the registered electrical energy manager. Okay, so Do you have this Associate Professor Dr. Hayati, who are expert in air conditioning system energy efficiency. So in short, we have men power from different background, different expertise. Also, we have the Associate Research Fellows, okay, Professor Dr. Sevia, Dr. Shafi Suhada, Dr. Amir Jan, and Dr. Natra. This is maybe not from purely electrical power, but have this contribute to the work of this center. Okay, right. So we have staff, one research officer, and 2 assistant engineers. Right. Some of the featured research we have this solar PV car charging for this is a car park. Okay, it's still ongoing. Okay, we have the solar PV already currently is connected to the lab, so they can monitor the electricity production from the PV. The next part we to develop the charger for electric vehicle. Then also we have another get connected photovoltaic system with smart home automation system for UTM Eco Home. This is UTM Eco Home. Maybe those who are outside, maybe one day you can come to UTM and you can visit this UTM Eco Home. Right. So this is some of the PhD research works. Okay, try to address the challenges that I already said. Just not too many. This is just selected. Okay. Right. So this is some of the consultancy's work. Okay. This is some just selected some of the companies that we involve, whether as the funder or we just collaborate or the client. Here's some of it. I think that I would say the major construction project is here. What we did around 2010, 2012, power quality baseline study in Peninsular Malaysia. This is a very big project. It's a cost of 3.4. The project value, the UTM received at 3.4 million. The funder is a KETA at that time and Suruhanjaya Tenaga. So we installed this power quality online monitoring at 50 sites in Peninsular Malaysia for 1 year, and also we do the power logging of 500 sites in Peninsular Malaysia. We want to know, okay, because I already mentioned just now the issue of power quality is very important. So we want to do the study, okay, how actually the baseline, power quality baseline in Malaysia. We already conducted it through this consultation project. This is actually a part of the project. This is actually part of the power quality social as part of the project. We have to conduct this symposium as part of the project commitment. Okay, this is some of construction project with Ryan Hill. We do this electricity conservation measurement and verification project. This is also we do lots of energy audit. To name a few, Prodio Manufacturing, Majlis Bandar Kulai, okay, GPA, PSD, and Ministry of Natural Resources, Putrajaya. This is actually the training we conducted. A short course on efficient energy management in commercial building. This course is a professional course, is ST approved. Okay, we conducted this. In fact, I said this as the previous participants. In fact, this short course is actually listed in Energy Commission website, official website. You can see we are actually the provider of this short course. Right. So we do some community services. Okay. Campaign Perkhidmatan Electric for school children, for these college students. Also, we also did one in the audit for school. This is an example. This is March 2020, just before MCO. We do this energy audit. Right. I think that's all from me. Okay. I think a bit more than 40 minutes. Okay. Sorry about that. But thank you for listening. So I will pass the webinar to Prof. Kamal for the Q&A session.
Okay, thank you very much, Professor Dr. Muhammad Pauzi Abdullah, for sharing a very, very interesting and very good sharing session to all the viewers about this energy, as we know that we use it every day. Okay, now I would like to open for Q&A. If you want to ask on this particular topic related to the energy system in Malaysia, you can just writing at the comment of your FB Live here. Okay, before we start, maybe I can have one question for you, Dr. Pauzi. Okay, as we know that for the past few days or week, the most hot topic in Malaysia related to electrical energy is high electricity bill during 3 months MCO. many public blame TNB, okay, for many reasons. Can you comment on that?
Okay. Thank you, Prof. Kamal. That is an interesting question. Yeah, especially this is the most hot topic for the past few weeks or few days, that translated that to Malaysian government or at around 1 billion to help people to help in reducing the electricity bill. But right, okay. Before I want to answer, you must understand that, okay, MCO, this COVID-19 is something new. We never faced it before. Okay, so most people, maybe some of the people are affected to this. Some of them may lose their job, right? So any increase in electricity bill, we suffer that. We must understand that. Okay, right. So this is something that I think is a challenge for the government and also a challenge for the MB. Right. Okay, to answer that question, first, I think that the issue, okay, actually I read all the comments from Facebook, okay. Some of the comments are very emotional, okay, and some of the comments a bit, yeah, I would say most of the comments are emotional and blame TMB for it, okay, and maybe blame the government. But I think the main issue here is actually, I think I can summarize is two things. I think the pro rata method and the estimated billing. Okay, because I think that the issue is, okay, the city bill comes after 3 months, and TNB used the pro rata method to give the city bill, and then you have to pay high electricity bill. Okay, well, I think that the problem, I already shared one slide about that. Okay, the problem is most of us, okay, we don't know how our electricity appliances at home actually consume electricity. Okay, right. So that's what I said just now. If you use 2 times more, your electricity bill will not be twice; it may be triple. Okay, because of the increasing block tariff. So right. So that's why when the customers, okay, read your electricity bill, you should not look at how much you pay, because the final billing as a result of complicated calculation. I would say calculated calculation, okay? Because there you need to have the pro rata first, and then you have the ICPT, and you have KKWTB, and then you have final bill. I think customer must realize that the most important thing you must look at is what is the kilowatt hour consumption. That is actually the first thing that we should look at. Okay, right. So when you receive your electricity bill, you must understand that you have to look at what is your previous reading, what is the current reading, you must calculate, check, is it correct? You have to check first. If you feel that the bill is actually higher than usual, you should check. Okay, because it happened to me before. TMB, okay, read wrongly. Well, you have to admit the meter is a machine, okay, no problem with that. But the reader is human. They do make mistake. What happened to me is it's supposed to read 1, it reads 7. See how big different it is. Okay, the bill coming 100, more than 1,000 ringgit. It quite surprised me. But okay, I know something, so I check. Okay, wrong reading. So I just call TMB, I want to report wrong reading. They come the next day, they check again, they give me a new bill. So that's why you need to understand. You must check your total consumption. Don't look at the total bill that you have to pay. Okay. Once you check your total bill, then check. Is it for 1 month or 2 months really? Okay, okay. So that's where you have prorate. If the bill comes after 30 days or just 1 month, so the prorate is 1. Okay. And then if more than 2 months, then prorate is 3. If for 3 months, prorate 3. Right. Actually, okay, it's no problem with prorate. Actually, the prorate will benefit customer more than benefit TMB. Right. Because I already shared a slide about that. If you look at the domestic customers, 200 kilowatt hour, the first 200 kilowatt hour for the lowest rate, just 200 kilowatt hour. So if the pro rate is 3, 2 times 3, you've got 600 kilowatt hour at the lowest price. So I think it's fair enough, but actually for me, it will disadvantage the MB. It will benefit customer, but that's the way they calculate. So I think it's very clear. Okay, but you cannot actually depend on total price. For me, you need to know. I think my colleagues, many of my colleagues already shared some of the videos on how to calculate the electricity bill. I don't want to share it here. It will take longer time unless I do another webinar. But you can check in Facebook. My colleagues already shared on how to use this for rate. Right. So that's the way. I think no problem with that. Okay, because your meter is still the same meter. Okay, if you don't have problem before PKP or before MCO, why you have problem now? Okay, you still have the same meter. Maybe if there's a mistake, maybe the mistake from the reader. That's why you have to check first. Okay, but like I said, you must know how your electricity consumption, how you use your electricity. Basically, anything with heating and cooling also will consume more energy. And also, it also depend on weather. Maybe if the weather is too hot, okay, your aircon need to work more. The compressor have to work more. Of course, it will consume more energy. If you live at home 24 hours, okay, the many times you go to the refrigerator, keep open and close, keep open and close, it will increase the electricity. There's so many factors. Okay, it doesn't matter. But again, you must understand how you use electricity. This is actually the problem. Okay, then right. Okay, but I think but I'm academician. Okay, I don't pick size. Pick side. Okay. I think, but if I want to give criticism to TMB, I would say the use of estimated bill is also contribute to the problem. Okay, because yes, okay, well, I think if you use the estimated bill just for 1 month is acceptable, but for straight 3 months, I think it will give lots of customer a very will not happy with that. Okay, very simple, right? Okay, I have a shop. This is my bill for March, April, May, June. I close my shop, but my CC bill I still to pay. Why? Because they only use the method that they use is based on the previous bill. Of course, people the customer will question about that. I don't use anything, but I still have to pay. Right. But for those who understand, it's just like upfront payment. Okay, after the real bill comes, the company will calculate back. Okay, we will offset back whatever you have paid. If you understand it like that, yes. But you have to remember that, like I said, this is not easy time. Okay, maybe the business becomes too they lost everything for 3 months. Okay, they expect then you have to pay that bill. So of course it will cause unhappiness. Okay, the customer will be not happy with that. I think that is actually the issue. The use of 3 months estimated bill, and also the method they use to 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 calculate the estimated bill. That is that. If I want to give criticism, that's my comment on that. But again, well, we have there many other factors. Okay? But hopefully, all these issue maybe in future, once we have the smart meter, no problem. We don't have this face. We'll not never face this problem again. Okay, because we can know how much we consume this hour or this day or 3 hours, and straight away TMB also can know how much your electricity bill for that month. Straight away use apps. Okay, this is your electricity bill. Maybe in future we don't have that problem anymore. I think that is actually my answer, Prof. Kamal. I think.
Okay, thank you. I think there is one question here. What is our alternative energy source for Malaysia? I think from M. Fadil here.
Alternative. For me, now, well, okay, other than solar, we'll talk about biomass, but again, we still don't have that much, okay, because it still depends on the location. For me, currently, the most promising renewable energy in Malaysia is still PV. But again, PV alone will not help. I said, remember that the slide I shared about the duck curve, California duck curve. If you have lots of renewable energy like solar PV in the system, of course you solve one problem, but you create new problem. That's the issue. So that's why we have to address that. But currently, to answer that, the most promising right now is the solar PV. So that's why lots of effort, lots of policy, lots of incentive being focused on increasing the power generation from solar PV. Whether it is at the customer side to this small scale, meaning that it's a few kilowatts peak solar size, up to, we talk about utility scale, large scale solar. Up to, currently in Malaysia, the largest is 100 megawatt peak solar farm. Okay. The question.
System in Malaysia.
Okay, right. So I think, okay, if you want to invest something in electrical energy system, okay, the next big thing will be energy storage. Okay, currently the current energy storage technology right now is too expensive. Okay, but maybe in 10 years time, 20 years time, it will be reach the economy of scale. Okay, the price will be competitive. Why? Remember I said talk about this the duck curve. Okay, if you have energy storage, then it will solve a lot of problems. Okay, so maybe during daytime, okay, some of the energy generated by the renewable energy can use to charge or can store in the energy storage. There's a lot of energy storage. Okay, you store that. So during nighttime, you can use that. Okay, during nighttime when you don't have no longer sunlight, you don't have output from solar, you can this energy storage. Okay, to supply the electricity, you can have solved this ramping problem. Okay, so lots of currently lots of research talk about this energy storage, how to optimize energy storage. We talk about utility scale, a very big energy storage, or we talk about customer side, meaning that at every home we have our own energy storage. There's even people start talking about whether we can use electric vehicle. Let's say you have Tesla, right? Maybe at home, once you go back, you still have this electricity left in your battery. You want to sell back to the utility, just like you want to sell back to the end. People start talking about that. But again, that is still a concept. Okay, still the main challenges is cost. But maybe perhaps in 10 years, 20 years from now, the price becomes very competitive. Okay, so maybe we will have that technology available commercially. Okay, so that's my. If you want to answer, the next big thing in electrical system will be energy storage. Okay.
Okay, thank you very much once again to all the questions. Now I would like to pass over to Puan Sharifah Ujama for the closing remarks of this webinar series and our next webinar series for the Research Innovation School of Electrical Engineering. Over to you, Puan Sharifah Ujama.
Thank you, Prof. Kamal. And once again, I would like to thank our guest speaker today, Associate Professor IR Dr. Pauzi Abdullah, for sharing with us the interesting topic for today. Now we all know why our electricity bill suddenly increasing during MCO. And of course, we have to double check our bill now. Okay, viewers, we are at the end of our session today. To all our viewers, thank you again for watching this live telecast. And please don't forget to like, comment, and share our Facebook and our videos to all your colleagues and friends. Okay, please join our next session of webinar series for next week, 30th of June, delivered by Dr. Musa Muhammad Mokji, Head of Digital Signal and Image Processing Research Group, on the topic of signal processing and computer vision empowering artificial intelligence for IR 4.0. Thank you all. Stay safe, keep your distance, and stay tuned. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.